Hey, so let's real quick look at some word problems that use quadratics, and really you should know how to kind of set some of these up just from past experiences in other classes or life. So let's just go through the first one. The area of a rectangular garden is 14. One side is twice as long as the other. What are their dimensions? So I have a rectangular garden. And I know the area is 14. I know when I have a rectangle, I usually have two dimensions. I have length and width. So when it's saying what are the dimensions, I'm trying to find out what L is and what W is. So remember, we always want to know what we're looking for. Okay. And I know the area is 14. Hopefully you all remember that area is length times width. So I have 14 equals length times width. And I was given something else. One side is twice as long as the other. So one side, pick a side, I'm going to pick L. So L is equal twice as long as the other. Twice as long would be 2 times W. So 14 equals L. L, though, we already said was 2 times W, so we're going to sub that in. 2W times W. So 14 equals 2W squared. Now I can solve for W. Divide by 2. W squared equals 7. And W is going to equal plus or minus square root of 7. Since this is an actual length, we don't want to include the negative root. We can't have a negative length of a board or length of a garden or length of anything. So W just equals square root of 7. Well, L was 2W, so L just equals 2 times square root of 7. So L would be 2 times square root of 7. So if you have an area problem, it's just setting it up like any area problem you've ever done in the past. Let's look at another type of, geometric word problem. So we got a right triangular planter has a leg that is 2 feet less than the longest leg. The third leg is 2 feet. How long is the longest leg? Okay, so I got a right triangular planter. So I'm going to draw a right triangle. Right triangle means it's got a 90-degree angle. And the longest leg is always a hypotenuse, that leg across from the 90-degree angle. We're going to call that C. And that is what we're looking for. We're looking for how long is the longest leg. So I'm trying to find out what C is. Okay. Let's go ahead and try to figure out the rest. It has a leg that is 2 feet. So a leg, we'll call the other leg something. A and B. That is 2 feet less than the longest leg. So we're going to pick a leg. I'm just going to pick A. That is going to be, so is equals, so A is going to equal 2 feet less than the longest leg. So less than is minus, so C minus 2. Okay. The third leg, that would be our B, is 2 feet, so just 2. Okay, so hopefully you all remember an equation for this. It's called the Pythagorean theorem. Came out of the school of the Pythagoras that set up in Etrusca, I think. Doubt he actually derived it. But it's going to be A squared plus B squared equals C squared. So if I sub in C minus 2, whole thing squared, plus 2 squared equals C squared. Okay. Got to solve this, and I know I have a binomial squared, so I'm going to write it out twice and FOIL it. I'm going to do it in my head, but you all can write it out twice and FOIL it. C squared minus 4C plus 4. 2 squared is 4 equals C squared. Trying to solve this, well, my C squareds actually cancel out. So I don't even have to worry about getting everything to one side. So I have negative 4C equals, I'm going to move my 4 to the other side, negative 8, and C equals 2. Okay, so I have, that's all I wanted. I just wanted the length of that was C. So my last one, I'm going to have a right triangular area has the shortest length of 5 inches. The length of the longest leg is 3 inches longer than the third leg. And actually, we're going to make that twice the third leg just to make it more interesting. So I'm changing it right now. What are the lengths of each leg in the triangle? Okay, so again I got a triangle. I know the shortest length of 5 inches. So the shortest leg, doesn't matter if I call that A or B, it just can't be C. That one's going to be 5. I'm going to call that A just because it was the first one. The length of the longest leg is always C. So is equals 3 inches longer. So that'd be plus 3 plus twice the third leg. So 2, and my leg I haven't used yet is B. B is just B. I'm looking for the lengths of each leg, so this time I'm looking for A, B, and C. I'm going to set this up. I'm going to have, again, Pythagorean theorem. Whenever I got a right triangle, I can try to use that. So A squared would be 5 squared. B is just B, so B squared. C is 3 plus 2B squared. Okay, so 25 plus B squared. Again, I have to write out this binomial twice and FOIL it. 9 plus 12B plus 4B squared. It is a quadratic. Get everything over to one side. So I can try to factor it. So I'll subtract my 25 and subtract my B squared. Get 3B squared plus 12B. If I subtract the 25 minus 16. Okay, and now I can either factor it, complete the square, quadratic formula. This may be factorable. I don't really know. I'm going to go ahead and just complete the square though. So to complete the square, I'm going to divide everything by 3. And same time, I'm going to move that minus 16 over 3 to the other side. So I'm going to come up here and complete the square up here. So I'll have 16 over 3 equals B squared plus 4B. If I complete square, I'm looking for that third term. So let's see. B plus 2 and B plus 2. So that third term would be plus 4. So plus 4 on the other side. So B plus 2, whole thing squared, is going to equal 16 plus 12, because I have to get a common denominator, would be 28 over 3. Okay, so take square root of both sides. B plus 2 is going to equal square root of 28. Can't do, but I can simplify. 4 and 7 give me 28. So 2 square root of 7 over square root of 3. I can't simplify square root of 3. So I'm going to get B to equal 2 square root of 7 over square root of 3 minus 2. Now I can rationalize this. I shouldn't leave a radical in the denominator. This one's getting complicated. It's kind of fun. So rationalize, I can just multiply top and bottom by square root of 3. Get 2 square roots of 21 over 3 minus 2. Can find a common denominator. And that would give me 2 square roots of 21 minus 6 over 3. So this is what B equals. So B equals 2 square roots of 21 minus 6 over 3. A equaled 5. I was given that one. I still need to find my C. C is 3 plus 2 times B. So let's see if I can find that. Gonna, I guess, come further over. C equals 3 plus 2 times 2 square roots of 21 minus 6 over 3. Find a common denominator again. So I'll have 9 over 3 plus, distribute, 4 square roots of 21 minus 2 times 6 is 12 over 3. So my 9 and my negative 12 should be a minus 3. So I should have 4 square roots of 21 minus 3 over 3. And that's about it. So again, a little weird. I could have done this using quadratic formula. Turns out it wasn't factorable. So I would have had to use quadratic formula if I didn't use completing the square. But still, once I had it set up, it was just using stuff we already knew to solve it. Okay,